Hi there, well I bet you all thought you'd seen the last of this thing. I stuck it on eBay to see if anyone's interested in buying it, and it was actually bought by somebody who actually bought it to see it torn down. So thanks to Rob in Australia, let's get cracking. Right, first thing I'm going to do is just de-vacuum this, just to avoid any implosions or anything nasty happening due to the vacuum. So I was going to use a diamond burr to grind off the sealing pip until it releases its vacuum. What we should see here, this silver here is the flash from the getter, which is used to take the last bit of air and other gases out of the tube. So what we should see this turning white once we get some air in there. There we go. You see this stuff just slowly oxidising. I'll just leave it there. And right, the thing I'm most interested in is the Intensified bit, so I'm going to try and sort of detach the vidicon from it. Now what I'm going to try is something which I've read about but not actually tried myself, which is to actually use a hot wire wrapped around the tube to produce sort of some heat stress in a very controlled area, to see if it can actually cut around this, sort of like this. So I'll just rig this up. This is a bit of steel, it's actually a guitar string, so we'll wind that round, put a bit of tension on it and then stick some current through it to heat it up and see if we can crack this tube in half cleanly. Right, I've got the wire wrapped round with one end anchored and connected up to the power supply. So I'm just going to keep this under tension and then stick some volts into it. Right, the first bit of wire snapped before I even got a chance to do anything, so I'll use something a bit thicker this time. Let's crank the current up. So 8 amps, I'll take it all the way. Right, 10 amps going through that, got a little bit of smoke. Turn it down a little bit, start to glow. Make sure we're not shorting it at the joint. Maybe if we let the wire heat up a bit. Oh dear. Need to find some stronger wire. Right, so the hot wire method was a bit of a failure. I'm going to see if I can just score a line around this with a conventional glass cutter. It's easy. Now what I don't know is whether the Intensified shares the same vacuum as the vidicon. Let's see if I can figure that out. Some sort of target on the front of it is very thin, maybe a thin layer of metal or something on the front of the vidicon. Just crack the other end of the vidicon off so we can have a look at the electron gun. I'm guessing this is a fairly conventional gun like you see in a TV or scope tube. Right, so you can see the structure of this. These are sort of glass supports that hold all the bits together and also hold it against the outer envelope. Here we see two of the getters. These that contain the metal which is used to get the last bits of gas out of the tube after it's been pumped down. They put a coil on the outside that makes these get really hot, and that's what deposited those silvery marks on the outside of the glass, which are now pretty much completely gone. There's just a tiny little trace left, so the metal the stuff sort of vaporizes out and condenses back on the glass, absorbing any oxygen or other gases in the process. And you can see sort of the various electrodes, this big sort of, I'm guessing that's the final anode, and then there's separate sections here that the electron beam goes through, and in the bottom here there's going to be a filament. If we just take this apart. So here's a hole through the middle for the electron beam to go through, so I'm guessing it's focused down to a parallel beam here, and then it's deflected by the external magnetic fields as it gets accelerated through this tube and then hits the target. So yeah, I think that's the final target there, because you can actually see there's the external electrode, which is the signal output, is connected to this piece. So I'm not quite sure what this is. Obviously, presumably the electrons have to go through it. I'm not sure if that's a metal foil. Yeah, I think it could be an extremely fine copper foil or something. Maybe that's doing something to the electron beam. Not quite sure what. The rest of that's just a cylinder. Again, there's another piece that's, maybe it's to control the speed. There's a sort of little pinhole there, but it's actually covered by some metal. That's also thin foil. Yeah, it's fairly thin foil. Maybe that's, don't know, some sort of filtering or something. I don't know enough about this stuff to know what that's all about, I'm afraid. Just about see some filament wires in there. Maybe if I stick some volts through them, we might see them a bit more clearly for a short time. There we go. There's a tiny little pinhole there for the beam to come out, and it's popped. Right, looking at this, I don't think there's a separate vacuum fill. I can't see any separate vacuum filling point here, and there is some channel around the side, but also there's this thin window here which, if it was under vacuum at the back, would be bowed in quite significantly. So I'm just going to cut this. Yeah, I'll just ping straight out. I'm guessing that's the silicon target that they mentioned, and it looks similar to silicon wafer, so that's probably a very thin film of silicon. So that's what the electrons coming out of the intensifier hit and then picked up from this electrode here. But yeah, this is very, very brittle, so this is clearly a very thin film of silicon. Can't really see a lot. We can actually start seeing through the tube now. Just come right underneath it. You're actually seeing the output of the fibre. This is just a sort of conical cavity. I think these ceramic parts could take a bit of breaking. So yeah, that just seems to be a sort of conical section. Looks like there's a lens of some sort in here. All I can see is the reflection off of it. Maybe there's a sort of hemispherical inner surface, and it looks like some conductive film on the inside of this ceramic. So not hugely interesting. I suspect this front fibre bit is actually one piece, the sort of flat fibre face on there, and then there's like a concave surface on the inside. So the rest of this doesn't actually look like there's really anything of any interest. So let's just crack a bit more of it. Right, so we've got a bit of falling apartness. So yeah, this is just circular electrodes, nothing particularly interesting. And here we've got the fibre assembly. Right, so what this appears to be doing is it's taking an image, which simulates an image focused on the front by this piece of printed paper, and it's effectively projecting it onto the surface, on this curved surface. And I think there's a coating on this, and this is the coating that actually produces the electron emission in response to the low level of light. So we've effectively got this curved surface. You can actually see the effect of the lensing on it. So we're sort of taking this flat image from the front, projecting onto this surface, that's then emitting the electrons that again then get accelerated towards the target. So that's about it, I'm afraid. Not all that interesting, but I suppose the thing about vacuum tubes, the clue's sort of in the name, there's not actually all that much in them. The electronics around them are a little bit more interesting. Oh well. At least the money I've got for this has already paid for the next teardown target, which is a little bit more modern. So we'll take a look at that soon.